The average acceleration of an object can be determined from that object's velocity versus time graph. What we're going to do here is very similar to something we've done already. Compare everything here to the average velocity from a position versus time graph video. We're doing the same thing. Here we've got the graph of perhaps Hamlet's ghost now running about the castle, first with a positive velocity and then so on and so forth. See if you can pause the video for a moment and tell a story in words, convey what's happening in this scenario. From the graph, can you convert this into a narrative in words? Once you're satisfied that you understand what Hamlet's ghost is doing here, let's go ahead and look at the average acceleration between events D and E. I'm going to start by connecting those two events with a dotted line, and then draw this triangle. This side here we see represents the change in velocity from the velocity at event D to the velocity at event E. So that is delta V, the change in velocity. And here we see this side of that triangle represents the change in time from event D to event E. So from our definition for average acceleration, which is the change in velocity over the change in clock time over our time interval, we see that delta V over delta T, well, this is 8 meters per second minus -2 meters per second, final minus initial, over 32 seconds minus 24 seconds, which comes out to about 1.2 meters per second squared. Comparing this calculation to this little diagram we've drawn, we see that this delta V is the rise between those two events, and delta T is the run between those two events. In other words, what we've calculated here, 1.2 meters per second squared, we get that unit because we've got meters per second, gives us meters per second squared, gives us an acceleration. We take that velocity, the rise, over the run, and what we've got is the slope of that connecting line. And there's our key concept. On a velocity versus time graph, before we were looking at position versus time graphs, now we've got a velocity versus time graph. The slope of a line connecting any two events is equal to the average acceleration between those events. In other words, the average acceleration, delta V over delta T, the rise over run, is the slope of the connecting line. Look at a couple more examples on this graph. How about the average acceleration from events B to C, from here to here? Average acceleration is delta V over delta T. If I connect those two events with a line and draw in this triangle, that side represents our change in velocity. And from there to there, that is our change in clock time. Our delta V, final minus initial. Final is -8, initial is -2. Over a change in time, that's 18 seconds minus 8 seconds. Get our units in there. Which comes out to -0.6 meters per second, meters per second squared. And from the diagram, again, we see that our delta V, that's like the rise, and our delta T is the run, rise over run. We've once again calculated the slope of the line connecting those 2 points. The slope of the line is the average acceleration. Our average acceleration here is negative. At this point, the ghost is moving slowly in the negative direction, a small negative velocity, but by this point, it's moving very quickly, a large negative velocity in the negative direction. So we had a negative acceleration between here and here. Its velocity became more negative between those two events, thus the negative 0.6. Compare up here, its velocity became more positive. It started out with a small negative velocity, ended up with a large positive velocity. Thus we had a positive acceleration between those two events. Let's check one more thing here. How about between events B and D, between this moment and that moment? Well, if we draw a line connecting events B and D, and we go to our definition for average acceleration, delta V over delta T, well, our final velocity is -2, our initial velocity is -2, and our change in time, 22 seconds minus 8 seconds. Well, -2 minus -2 is 0. That's a horizontal line. The slope of a horizontal line is 0. Which tells us that the average acceleration between these two events was 0. It ended at the same velocity where it started. Now its velocity changed between these two events. It got moving faster in the negative direction, so it had this negative acceleration sort of from here to about here, but then it had a positive acceleration from here back to here. So that negative acceleration and that positive acceleration averaged out to be a 0 acceleration between these two events. All right, I want you to try a couple of these. How about find the average acceleration between these pairs of events, B and E, A and C, C and D. Pause the video for a moment, work those out. Got the answer? There you go, check those. And let's move on. Okay, here is the graph of another object's motion, its velocity versus time. And I've got a few events marked on here, and the question I have for you is, several questions I have. Can you tell me between which consecutive events, B and C are consecutive events, but B and D are not, they do not come right after each other. So between which consecutive events is this object slowing down with a negative average acceleration, or is it slowing down with a positive average acceleration, and so on? Study that graph and tell me between which pairs of events are the following true. Pause the video for a moment. Got it all figured out? Okay, here is our answer. Between C and D, that object is slowing down, its velocity is approaching 0. Oh, I guess I should have marked 0 here from the beginning, so you knew that this is 0 velocity, but you probably assumed that, right? So the object is approaching a 0 velocity, meaning it's approaching rest from here to here, so it's slowing down, but we see that the slope of that connecting line is negative. That's a negative acceleration. Its velocity is becoming less positive, it's becoming more negative. Okay, from A to B, the object is slowing down, it's approaching 0 velocity, but with a positive acceleration, because its velocity was negative here, and it is approaching 0. So the slope there is a positive slope, that's a positive acceleration. Between events B and C, the object is speeding up, going from 0 to a large positive velocity, and that's a positive slope there, positive average acceleration. Between events D and E, the object is also speeding up, going from 0 velocity, going from rest right here, to a larger negative velocity. So it's speeding up, moving away from 0, but with a negative acceleration. Its velocity is getting more negative between those two events. Okay, last set of questions. Between which of these consecutive events And does the object have greatest positive average acceleration, greatest negative average acceleration, and a 0 average acceleration? Pause for a moment. Answer is A to B, largest positive acceleration. There's two events, here to here where the acceleration is positive, and B to C, the acceleration is positive. That, we can tell, is a larger positive slope than that. This one we would have to tilt that way. We have to lessen that slope to match that one. So that's the largest positive slope right there. And then here's a negative slope, here's a negative slope, but from C to D is steeper than from D to E. And lastly, E to F, we see this object has a negative velocity, it does have a negative velocity this whole time, but it's constant. It's not changing. Same velocity at the end, at the beginning. Therefore, its average acceleration between those two events is 0. A horizontal line connects them.